So basically the idea of Ultimate Canola Challenge, or UCC, came about after a few beers after Canolab, and what we wanted to do was a battle royale between Murray Hartman here and Neil Harker, who's also based out of Lacombe. He's a weed scientist there. We wanted to see who would have the biggest, best canola crop. And we were going to we had a pretty good idea on how we were going to do it. But in talking to Murray and Neil, they sort of thought they would maybe do the same sort of thing. So they weren't as interested. But we, since then, have sort of evolved our UCC plots into basically what happens with canola when we do everything right. What can we do to get the best yield? And is there any extra product that could potentially push us a little bit higher? So as canola council agronomists, and Murray here as well, we've been getting lots of questions about some of these seed primers, micronutrients, foliar feeds, you name it, we get questions about it. So we thought, in addition to our do everything right, let's try out a couple of these products that we've been asked about and see if maybe there's some sort of data we can get. Because at the moment, we don't really have much for independent data supporting them. And so in that case, we can't really talk about them in an educated manner. So we picked out some of the products that we got asked about the most, and Murray will go through them here in a second. We'll take a little walk through the plots eventually, but I think we'll probably try and stay behind the wind fence for a little while and then head over. But so some of our treatments include extra seeding or extra seed, extra fertilizer, and the idea there is if you have an extra $5 or $10 an acre, maybe we should try spending it on something that we know is going to work, and then we'll try some of these other products. So if we do see a response from some of the other products that we'll go through, that's definitely a bit of a proof of concept, and we can go forward and maybe do some testing on them in the future. So if you guys have any questions throughout the presentation, please interrupt and ask us. We probably both like as many questions as possible and keep this sort of as a dialogue. So without further ado, here is Murray Hartman.
Good. Okay, what Autumn didn't mention is that we have these trials at 10 locations across Alberta. There's actually a few in Saskatchewan. They're not all the ones, like these has 13 treatments. Some of the locations only have 6 treatments. So there was kind of a high and a low level of intensity. They're all replicated small plot designs. So, and so doing things right for canola, seeding rate is always a topic of discussion by producers, especially with the cost of hybrid seeds. So how many pounds per acre should you be seeding? What is the best management practice for that? And my answer always is, I really don't care what you're doing. I just really care what you've got coming out of the ground. So your net effect is what I'm after, and I want to see more than 4 plants per square foot emerged, because when I did a review of all the studies, a whole bunch of studies, there was a point where you started to get 10% yield loss. It's called kind of a critical point. That was at 4 plants per square foot. So once you started to go down, and there was very little difference between open pollinated and hybrid. So that's the point that you really don't want to be on the low end of the stick. So to target plants, you don't want to target 4 because things always go wrong, frost or flea beetles, etc. So you really want to target probably 6 to 8 emerged, right? What's the average emergence for canola? Anybody have an idea? 50%. That's a really good average. So a very good year, like this year at Lacombe, we're finding 75, 80% emergence. But other years we've been under 50%, even in the black soil zone in Lacombe. In drier areas, you probably would be pressed to have, emergence above 80%. So if you say, well, I'm going to target 50%, I want to have 8 plants per square foot, that means I'm going to have to plant 16 seeds per square foot, right? And then you can do your seed count, et cetera, and work backwards. And there's so many other factors that go in there. How much fertilizer you're putting in the seed row, your residue, your seed soil contact, all that kind of stuff. So it's really hard to say, oh yeah, this many pounds per acre with this variety will work. You really got to say, okay, what did you get come up? If you're under, you got to do something different. It might be more seed. It might be take fertilizer out of the seed row. etc. But if you're over, say you're 8 to 10 plants per square foot, consistent, you can say, well, I guess I have some latitude to reduce a bit of my seeding rate. All right. So that is one of the things that you've got to do right at the start. The fertility side of it, I traditionally look at a nitrogen application of getting, for many guys now, they're shooting for 40 to 50 bushels an acre. Down here, I'm suspecting maybe it's 30 to 40 off not irrigation. And to get that kind of fertilized yields, you do need a fairly high rate of nitrogen. So the areas where they're targeting 50, they probably should be targeting 100 pounds of nitrogen. Fertilizer application, it depends, of course, on your soil test. And I always say, okay, if your soil test plus your fertilizer nitrogen application should be 100, 150, 160. In a drier area, might be a little less, might be 120 to 140. But so that's nitrogen, phosphorus. Soil tests are pretty decent for that, but you have a limit on how much phosphorus you can put in with a seed, because if you put 100 pounds of 1151 with the seed and you've got a fairly tight seed row, you're actually going to hurt the germination and reduce your seed count, the emergence. So phosphorus is one that does have usefulness with the seed. All the other nutrients basically don't. So if you have the capability, only keep phosphorus with the seed, we won't put everything else outside, sideband, or even broadcast if it's ammonium sulfate. Early weed control, I think that message has been bought in for the most part, but that's another one of the best management practices. And then scouting for insects and everything like that. So we've got one treatment here that's kind of our best management here, and it was 100 seeds per square meter, so 50% emergence. That's only giving us 5 plants per square foot, roughly. So that was right at the bottom end of what we would say for the seeding rate. And we're using a herbicide-resistant variety. I think they're Roundup Ready in here, and early timing. And the fertilizer rate, because this is under irrigation, it had a lot of fertilizer. If you look at the soil test, it had 130 pounds a hand, but we added 70 on top, because with irrigation, that's about what would be an economic response. We did have one where we put on 25% more than that. So if you're going to spend extra money, like Autumn said, lots of times maybe it's just better to spend it on the one macronutrient we get the most response of. We also have one where it's 75% rate of nitrogen, and that's for those, I guess there's 2 values for that. One is a lot of guys maybe are under fertilizing in a dry soil zone and saying, well, we don't ever get a benefit. So you show them what the yield you would get at the lower rate, but also you get a dry year and you would say, well, yeah, we could tell that at this much moisture, that lesser fertilizer rate probably had the best economics. So there's a good reason to keep it in that. We also put an in-crop treatment of nitrogen on to bring us up to that 125%, and that's to show you that if you're targeting a dry year and then the weather conditions change after seeding, like you get a wet year, what is the response of the canola to having some in-crop nitrogen? Obviously it's, from a lot of the specialists will say it's still better to put all that nitrogen down before seeding. But if the conditions change and you realize now that you were underestimating your yield potential, then what is the benefit of having some in-crop nitrogen? Because it's starting to be a more common application. So that's one of the other ones that we are looking at. Then we have a number of different treatments here that are including, so we've got 2 different primers, and they're basically, the one is micronutrients that are applied to the seed, and the other one's micro and macronutrients applied to the seed. And in some crops around the world, that's how they do apply their micronutrients quite successfully. Of course, they're micronutrient deficient soils, and that's not necessarily the case here. And they also work better also on larger seeded crops, because a larger seeded crop, you're putting more pounds per acre of that crop on, you're putting more micronutrients on, but versus canola, 5 pounds an acre, you're not, no matter how much you coat the seed, you're not getting a lot out there, right? So there's a lot of questions that, coming from producers and soil fertility specialists saying, well, we just don't think you're going to get a benefit from that sort of things, but the data is pretty sparse. So we've got two different of the seed primers that we've put on here, Proteus and Precept. Then we've got some treatments where we're applying different foliar nitrogen things in crop one, for example, C3 is just the macronutrients, and then we've got other ones that are macro and micronutrients, and then we've got one where it's boron applied, one at the 4 to 6 leaf stage, and one at the more traditional timing of an early flowering stage, which we haven't applied yet, obviously. And the theory is if you apply a micronutrient, sometimes the crop is taking up the fastest amount of nutrients from the bud stage to the early flower stage. So if you're deficient at that point, it might affect the yield later on, and that's why some people are, in theory, are saying, well, then we should be applying these micronutrients at before it's bolting, because it's already having a heavy draw, and we don't really have any data on that. And it's theory, but we've got that one in this treatment also. So one of the things I wanted to talk about, though, is related to this poster from Manitoba, from a soil fertility specialist there, and it illustrates the misconceptions that some people have about statistics. And when you hear that often, well, it's a 5% level of significance, what does that mean to you? You know, well, we have a 95% confidence that those are the results, right? But really, what it's also saying is that we're at 95% rule, we are assuming on average that we will get 1 times out of 20 when we get a statistical response that was a false positive. That's what that means, okay? If you're at the 10% rule of significance, 1 times out of 10, you're gonna get a false positive. You know, and so this was a really interesting study from kind of a demonstration study from Manitoba. What they did is they had this a block of actually soybean stubble, and he took these 4 treatments. He took, a check treatment, no nitrogen and none of this foliar. He applied 60 pounds of nitrogen as urea. Then he applied the urea plus this foliar product, and the foliar product was diluted maple syrup. Okay, so not really, any evidence that's going to do anything, but just showing, well, this is what I did. And then the other one, he put 120 pounds of nitrogen on. And this was repeated 3 times. So we have 4 treatments repeated 3 times. We have 12 strips, right, in a block design. He did that at location A. Then he took that whole same experiment and he repeated it at B. And then at C and D. So this is like mimicking, if I had this trial done at 20 different fields, locations, right? So, but he just stuck it all on the same field. Now, we wouldn't expect to see a response, right? Except, so that's how he did it, these 20 different locations. And this is the yield of that foliar treatment versus the check. So at location A, at location N. So you can see that sometimes it yielded less, sometimes it yielded more. Most of the times, there's not a statistical effect at that location, except here there was 2 times this magical treatment out-yielded statistically the check. Okay, 2 times out of 20, he was using a 10% rule, significance. I would have said, on average, we would get 2 false positives. That's what those were. Now, marketing scheme-wise, right? Well, why don't we just, I'm the marketing now for this maple syrup magic wonder. I'm going to advertise in Top Crop Managers my product, and I'm going to say, look at these 2 sites, look at the response we got. And on average, all our responsive sites, this is the yield improvement from this enhancer. It looks pretty impressive, right? I'm not going to tell you about all these other 18 sites. I'm just going to say, look at these responsive sites. But they were false positives, right? So the real message is, whenever you see, selected sites or, this one location did this, you should always be asking, what are all the rest of the data you collected? So I like to see 15, 20 site years, and then I'll take a look at that if that's, a response or not. Because it's very easy to take this kind of stuff. Even though these were statistically significant at that site, overall they were probably false positives. And similarly, when he took there's these treatments and say, oh, well, if we were comparing to the fertilizer treatments, the check was here, and then the 60 pounds of N, and then the 60 pounds of N with the enhancer, and then the 120 pounds of N, this is biomass. We were just as good as 120 pounds of N, with only 60 pounds of N, but with our enhancer. But statistics-wise, those were all the same. This was on soybean stubble, and they had like 100 pounds of N, and there really wasn't a response to nitrogen. But numerically, you could, lots of times they won't show you those the letters of significance, and that looks like, yeah, there was a real difference. So you've got to be very careful when you see, selected locations or single site data. The other things I always caution growers on is, are they just showing you pictures of what the seedlings look like and say, look how much better this is? Or the root mass. Or another common strategy is say, this nutrient has this required function in the plant. Like calcium is very important in cell wall structure on the plant. So therefore you should be applying calcium, right? The function is not related to, are you going to get a response to that nutrient applied to your field, right? That's what you need to know, not, how required is it in the plant. So if we look at these, we've got about 15 minutes, and I think we should walk down these treatments and take a look and maybe discuss, some of what you've heard. And we'll have to maybe gather closely because I don't think we're going to carry this with us. And yesterday we actually dug out plants from the front, but they weren't that. Obviously, we've got all this different staging in these plots, and so you have plants that are big and small. And if you were selective, you could pick certain ones out of certain plots and compare, and you'd see a real difference. Or if you'd have to take 20, 30 plants from each treatment randomly and then do an average to really get a good assessment. That's not what you see in the pictures, right? It's always 3 or 4 plants here versus 3 or 4 plants here, and dramatic difference, right? So I think we should, any questions before I go on, like with this kind of stuff? Or another thing I don't like is testimonials. But I think that's a given. Okay, we've got about 15 minutes. So one of the difficulties is that somebody will say, yeah, we applied this on this in the field, or maybe even I did 1 strip in the field and I got a response. And I'm going, okay, so have you got a past history on that strip versus the rest of the strip that there's no yield difference? Is there nothing that could have caused that? And so when I used to do applied research up in the North Piece, I used to put up replicated large-scale strips, and 3 times across the field, 30% of the time there was a gradient of yield. And if I would have put up a single strip, and compared it to that, it would have been not a reflection of the treatment, but would have been reflected in the yield gradient, right? So, but if a producer, say, takes 10 fields, put 10 strips in each field, and then you could do a paired t-test over those 10 fields, and you find, yeah, okay, it's a response, then that is good data. One of the problems with micronutrients is, for the most part, they are very patchy, the response in the field. And copper is an example that way. Copper is one where canola, we don't typically get a response on, but we do get in the cereals. I'm not sure about the pulse crops. And so to say that copper deficiency doesn't happen in canola is not right. Around the world, they do detect copper deficiency in canola, but we haven't in Western Canada. But we'll get a deficiency in wheat or barley 100-fold faster, causing you before it would happen in canola. So you should have been already addressing it in your wheat and canola before you would even have to think about it in canola, right? So in this example here, like we've got some micronutrients in these trials. In Southern Alberta, if you've got a zinc deficiency, it doesn't happen over the whole field. It's probably going to happen on the areas that are higher pH, and which tends to be the eroded knoll tops. So if you were going to put up a strip across the field, you might not get a response, But if you're taking yield measurements all along, you could also, and this is what variable rate, that was, what Ross McKenzie's trying to do, is say, yeah, on the knoll tops, this is where we're getting a yield response, only on the knoll top. So there's some of this knowledge that we said, no, we're not getting a response because we've been thinking field level, but as we maybe move down to certain spots, we might be able to pick some of these more out. But from the standpoint of the probabilities, that's the other thing I always like to, stress is that if you're going to spend money on something, I like to advise people spending on something where you're probably going to get a response. And to me, that's more than 50% of the time, right? So on a field scale, or if you say, well, 50% of the time on the low spots, if I apply a certain thing, I'm going to get a response. If it's 25 to 50% of the time, I call that a maybe. And I wouldn't, because that's 1 out of 4, 25%. Now, you might want to apply it on certain cases or certain things and try to figure out where are those cases where that 25%. But if it's less than 25%, I'm going, that's an unlikely, and it may be due to this, or it may be just that the conditions have to be all right for you to get a response, and that doesn't happen very often, so it's very unlikely. So you shouldn't be spending money on an unlikely, in my opinion, So that's how I like to kind of boil it down. Do you see enough data? And for me, I like to see 15, 20 pieces of data, and then is it a good response half the time? Then it's probable. If it's 25 to 50, then it's a maybe. If it's less than that, unlikely, and I'm not going to spend the money there. So, I'm not saying that the field data isn't any use, but you just have to make sure it's measuring the right things, you got enough pieces of data that you make your decision on.
Another question, Murray, in
yep.
addition to agree with what he was saying there. In a study like this where the focal point is nitrogen and you're comparing some XYZ product to nitrogen, and as you say, you go for what's going to get the best response in the end. Was there any soil analysis done by John on every individual
block? Not in every individual block. Yeah. And that's why.
Source of a false positive?
And that exactly could be. Yeah. But it's still a false positive from the standpoint of the growth enhancer, right? Because it just could be happened by chance, and that's why we do the statistics. That there's spots in this field where was a bit better soybean growth, a little bit more left in the soil, the nitrogen mineralization, and by fluke you get all 3 reps of that growth enhancer on a spot that's higher yielding to give you that. So now you're saying the growth enhancer gives you that, when it was really by fluke that it happened every hot spot of nitrogen. That's still what we call a false positive, right? And that's why we do the small plots, to try to avoid the chances of happening to hit every good spot with that same treatment. But it will happen by chance, and this is what the 1 in 20, 5% rule, we don't want that. You could say, well, then why don't you be really hard and say 0.1% chance? Well, then, in order for you to get a treatment effect, you're going to have to find such a large difference that could have only happened by chance 1 in 100,000. And you're going to miss a lot of times a treatment effect that's probably going to happen in the field. So there's that compromise of false positives or false negatives. And that's why we kind of, in that 5-10% rule of significance, is kind of a compromise for that. Okay? Okay, we got about 5 more minutes, so I think we should just walk down these. Pennergenic, this is actually a group of compounds that would fall in the class of biostimulators, and we really don't exactly know what they're stimulating. It could be defense pathways, it could be hormones in the plant, and somehow stimulating it to better handle stress or recover or anything like that. And in some crops in some parts of the world, they're getting some responses to this. And we've gotten products now that are being promoted for that. So this Pennergenic P is an example of that. And this one had 2 applications already according to their label, like at a 1-leaf stage and later. This Agri Solution, this is Neil Harker's favorite because he says it stretches the bounds of his imagination the most. The idea is that plants are carbon dioxide limited, and so if we could feed them more carbon dioxide, like in greenhouses, they'd improve the growth and, you know, nutrient use and water use efficiency. This product claims that you spray it on the leaf surface and then it gets absorbed by the plant and releases carbon dioxide inside the leaf, and therefore improves photosynthesis. So like Neil said, this one is a stretch for his imagination. That's why he wanted it in there. Proteus is a seed treatment with 3 micronutrients. And like in some parts of the world, they do get benefits of seed treatment with micronutrients. Never been shown in canola in Western Canada or other crops actually. I'm not sure beans if they put any micronutrients on the beans. But it's possible, but with the amount of the micronutrients you're putting on the seed and a low seeding rate to get enough to make a difference, not likely, but we'll see. Stress relief, that's just 3 macronutrients. I think the analysis is like 6, 12, 6, and you put on a liter or something an acre on it, and yeah, it's supplying some NPK, but at astronomically small amounts. And they still say, yeah, the plant will respond to that, and it stalls during a certain point of growth, and this will help. So, okay, we'll see. Pre-seed is another primer of micronutrients and macronutrients. So if you look at these plots, I mean, this has been hailed, so it's kind of recovering, but you can see that the growth is so variable from within the plots because of residue, et cetera, that it's really hard to pull plants or look at root masses and see that there's really any consistent differences between the plots. But really, there's been no observations noted for any differences except for the one where we put on extra seed, which is Neil's other favorite, but he likes that one because he figures extra seed is sometimes economic. In this case, we had 50% more than about 60% immersion, so we're getting 6, 7 plants per square foot in our treatments. So to add extra seed to get us above that probably is not going to pay you this year, unless this is under heavy weed pressure, which isn't the best management practice. So we might not see we'll probably see an economic loss from putting 50% more seed here. The urea, 5 weeks after seeding, so that has already been applied in crop. A fertified foliar, so it's micronutrients plus macronutrients in crop at a little bit higher rates perhaps than the C3, but still really relatively low rates of nutrients applied. The 75% N rate, and when they did some green seeker measurements here, and the low rate of N had just as high green seeker measurements as the high rate. So there was a lot of nitrogen in this profile, and it's probably not being reflected in the small differences we applied in the actual fertilizer. This is the higher seeding rate, and it is the plant density counts really doesn't reflect this, but when I look at the overall plot, yeah, this does look thicker than the rest, and it should. 50% more seeds. You know, if you seed 50% more seeds, you're likely only going to get 10 to 20% more plants though. Remember, it's not a direct ratio. We've got boron, which is a little bit more, there are cases of boron response in fields or patches of fields across the prairies, but it's pretty inconsistent. And when I did a review of 44 trials that have been done in Western Canada, there was only 5 or 6 that had a statistical yield increase from boron. So what does that fall into? An unlikely. There was also 5 or 6 that had statistical yield decrease due to boron. So this one here, on a field scale, it's an unlikely, but I think there are parts of fields, certain conditions, you might get a response. Well, we don't know that yet. The soil test is not a good indicator of a boron response. So we'll do this 2 different treatments, one at flowering, which we haven't done yet, and then we put one at that 4 to 6 leaf stage. And the last one, so this is our standard, and you can see that some of these plots are not going to be very good because we've got some gopher damage too, and so this is what statistics helps us to try to, I mean, we should throw out ones we could see that has a problem, but statistics helps us maybe to throw out outliers also, you know. Standard, and then the extra nitrogen, and really I'm not seeing a response to extra nitrogen as far as the color. What you can see later is more branching. More nitrogen would stimulate branching if it's deficient. I mean, we had 130 pounds of N in the soil, and we applied 70 more. 125 is an extra 25 or whatever. Probably not gonna, it's too fine of difference to really even see that difference. So, what's that?
After seeding?
No, this is all done at seeding. So, probably about the same amount total nitrogen of this one and the one with the urea ammonium nitrate after seeding.
Sideband?
Side-banded, yes.
So it wasn't toxicity?
No. So yeah, we didn't put any nitrogen. The only thing that would have been is some phosphorus with the seed, and I'm not sure if you put a little bit of potash with the seed. Now, potash is one we typically don't get a response in canola. It's fairly good at accessing, it seems, the potassium versus the cereals. You have to get quite a bit lower in the soil test than you would with a cereal response. So it's one of these situations that if you got a responsive field to potash to canola, you should have been putting it on your cereals, and then that carryover effect from the potash, even in the stubble, will be good enough for the canola. So, sulfur, this site is fairly high in sulfur. We still did put some on, and we had discussions among the agronomists that said that when we're excess on the soil test, why bother putting any on? And some people say, oh no, well, because sulfur is so variable, you should still put it on here. In South Alberta, often there's a big whack of sulfur once you're 2 feet down. And you can be deficient in the top, but as soon as that crop roots down to 2 feet, which is about the bolting the flowering seed, it accesses sulfur and it won't respond to sulfur that we had applied. The other is irrigation. There's a lot of sulfur comes in the irrigation water, so the chance of getting a sulfur response here were quite unlikely, but we did put, I forget, 5 maybe pounds of sulfur on. A big whack? You know what? We can get 1,000 pounds an acre of sulfur in a lower area that's saline at the 2-foot layer. Traditionally, we see the sulfur, not changed dramatically from 12 to 24. You get the most in the 0.6, but in these soils, once the sea horizon gets within that 2-foot layer, we can have sulfur level goes up to 100 pounds an acre in that 2-foot depth very easily. And we do have that. I think they may even be in this book, but I do have the soil test data. So this is unusual though for the traditional canola growing area. We don't have that subsoil sulfur. It's just in the brown and some of the dark brown soil zone. All right, I think that's the end of. I think you have to go to the next one now, just with Newton over there. So I'll be around for lunch if you have to ask any more questions.